All right, I don't see my guest on my live stream here, but I'm ready to respond any questions you guys might have. I will take advantage to say that I have been revising some of the Udemy courses that you guys might be familiar with that I have published in Udemy. I have about 12 or so courses that I published in the past decade, and I'm always looking at your feedback to see what I can do to make improvements to that. In any case, I wanted to just start a monthly meeting for our EDME community. And so this is January 31st, and everybody was invited to come today and do Q&A. I wonder what kind of Q&As will you have, and what kind of answers I can provide you. Hopefully, we can connect in the future, either on the Udemy platform or on the live stream here using YouTube. Um, so while I'm waiting somebody to come on board, I think that someone may join us here, and I can take any questions we want to ponder to see how is that I can respond to you. Okay, so let's see. Just a couple of ideas here for those of you that have taken, especially the electronic related classes. I've been looking more and more at both virtual simulation tools that you can use to practice your skills and talents that you've learned, whether that's electronics or automation, robotics, or PLCs. I have been exploring a few tools, and as a matter of fact, there is one particular piece of software that I'm using, which is free to use, called Tinkercad, that I wanted to invite you today to join my class there for free. And in that Tinkercad site, I'm gonna throw there, different kinds of short videos on electronics and related designs that you can always learn, use, reuse, whatever you want to do. I will like to be able to serve you that way, uh, so that you continue to enhance your skills and talents in what you're doing. So the site I'd like to put out for you to join me is tinkercad.com, and there's a class link that I want to put out here in case you review this. You can join that site, and with the joining, you will be able to have access to all the things that I will publish there, namely electronics and technology and engineering related content using that particular piece of software that I mentioned, Tinkercad. So while I wait, I'm going to do a short demo here, see if I can switch gears. I'm going to do a short demo on Tinkercad using the various tools that we have available here. So let's see if I can, maybe I just share. we go. So you guys can see my window there, right? And at this time, what I like to do is I'm going to give you just a little bit of a tour. This is a pretty powerful virtual design tool. I'm guessing AutoCAD or a similar company is the owner, but I came across with this tool as I was exploring some virtual design tools. And so let me just show you here something very basic. I'm going to start with this circuit here. And again, you have the link to join the class at any time. Here is a circuit that you can see that I built just to show you the potential. Here is a light emitting diode, a resistor, and a power supply. And here again, you have a diode and a battery. It's typical to use resistors to reduce the current going into the diode. And so if I run these, I have both working diodes. Notice that this one has a little bit of a sign. It says that the current through the LED is almost 62 milliamps, while the recommended current is 20 milliamps. And so the lifetime might be reduced. So let's see. So if we want to know exactly how much current is flowing through that circuit in there, we can definitely make changes. And the changes I want to make is I want to add a multimeter. And I want that multimeter to be a current reading device. So I'm going to change that to an ammeter. I'm going to break this circuit in here, and I am going to use the positive side of the meter and the negative side of the meter. To connect. I'm going to change the color of that. There we go. So that's our new circuit. And let's run this circuit to see what we have now. And the current is reduced to 4.2 milliamps. That means that we're safe, but we also can change this resistor from a 250 resistor to 150. And as we do that, there should be more current flowing through the circuit. You see that? There's more current. We can also change the battery to a larger battery size if we want to, but that's just a little bit of a small consideration when you are designing stuff with LEDs. All right, we could have a larger source, actually, as a matter of fact, if I do batteries here. There's all kinds of batteries that you have. We can even use a 9-volt battery instead and replace this one for a 9-volt battery. And this battery will definitely break this circuit if we connect it just like that. So I'm going to add a resistor, and that resistor is on the positive side. Okay. And that's a pretty big resistor. It is a 1K resistor. Let's run these, and potentially this can explode. No, it's not exploding. So let's do some change in here. Change I'm going to make is that I'm going to place the resistor on the other side. And it's possible that this is a little bit too much. Well, the issue I have here is that this is the anode and this is the cathode. So I'm gonna have to flip around the resistor, right? To make this right. Okay. So one way to get around this is if we go around this circuit, multiple ways to get this. That's my red lead. Do you see that? This is the anode of the positive, and this is the negative. So that should work, right? So there we go. We can still check out how much current we're getting here, and I can just simply copy that multimeter, bring it over here. I can break the circuit in here, and I can definitely connect change this to black and run it again, and I'm getting about 7 milliamps, right? And so anyways, if you want to properly design this, you will spec out a lower value resistor, and we can always do that. We're gonna double that much current if we spec out this resistor to be instead 500 excuse me, 500 ohms. Running again, we double the current, and we could even go smaller for a 20 milliamp current flow with a 9-volt battery. So let's go ahead and do that. So that means that potentially 1/3 of that resistor, like if we did 350, let's see what 350 ohms does. You probably will get pretty close, right? Pretty close, 19.7. So you calculate these things out based on your design parameters and what you're required to do. But anyhow, that's a demo on using this tool called Tinkercad. And there's all kinds of things that you could do here. For instance, I can bring another meter, and that multimeter can be used to measure voltage, right? So we can check the voltage. We can check the voltage on and across the resistor. So let me change the wires in here. Okay, so we got some voltage reading there. It looks like we're reading something negative, and that's because of the polarity of the meter. This side is more positive than this side, therefore we should switch the wires. So I'm going to switch the wires. Put it right here. And this wire, I'm putting it right here. Okay, that way we're measuring properly. And there we go. That's reading roughly 1 volt, right? Which is all right for this kind of circuit. Now we can do the same. If I add another meter, I'm going to just copy and paste that meter. And with this meter, I'm going to try to check out the voltage. Okay. I'm going to change the color of that wire. Check the voltage. That looks much better, right? We're looking at 6.9 volts across the resistor. And that means that the remainder of the voltage is going across the light or the LED, right? And that's what it means. All right, so we're doing pretty good so far, so good. So again, introducing a virtual tool called Tinkercad, and I've given you the link so you can join my class and be able to see all the circuits that I'm putting out there for you guys. We could do a lot with this tool. I use it for regular classes, academic classes, but anyone can benefit from that. So that's an actual circuit that you can use to measure various kinds of electronic parameters. I am interested in finding out what the actual voltage across the diode is. So we can do that. Okay, let's try measuring the voltage across the diode. I'm going to change the color of that wire. Okay, and let's run it. And it looked like most of the voltage it's going through the diode itself. That's what you're reading there, 8.9. That's quite a bit for a diode. Okay, so in reality, a diode with this kind of voltage could be destroyed. These LEDs don't support more than 5 volts in practicality, okay? So there we go. That's your first circuit using Tinkercad. Again, you're welcome to join my class for free on the Tinkercad link. Create your own credentials and join the class so you can benefit from having access to that. All right, we're going 27 minutes into our conversation here. And at some point, I'm gonna have to stop since nobody showed up today. But let's just talk a little more about Tinkercad. I'm gonna go back and bring maybe other circuits so you can see Tinkercad. Let's look at power supplies in Tinkercad. So there's a variety of power supplies in Tinkercad that you can have, including batteries of four sizes, an adjustable power supply that you can adjust the parameters, and of course, along with that, you can also find other types of power supply, including I'm looking for a function generator. So function, that would be an AC. There we go. And this is another type of power supply. With this function generator, I can generate different kinds of sine waves, right? Including square waves, sine waves, triangle waves, and so on and so forth. And, you know, with the batteries, I could generate voltage for different purposes. There we go. I'm going to turn it around. So we got all different kinds of power sources. I have never used here a solar cell. I don't know if they have solar. Yeah, so they do have a solar cell, which, as you guys may know, the solar cell is a type of source, right? So let me just place it here. I'm going to rearrange my tools here. And there we go, we have a solar cell. Okay. And it's you can make up any solar source you want in this virtual environment. Various kind of levels of currents. If you are going to design something here in Tinkercad using solar cells, I would recommend that you do a search on the specs of the types of solar cells you're going to be using, because they're all spec out voltage, current, and amperage and wattage. You can design whatever you want in the virtual environment, but there are some standard specs that OEMs put on solar cells. Okay, so these are all kinds of sources that you can use in this world of virtual simulation tools. And as you can see, it's more than electronics. It's a lot more than electronics. You got a lot of things that you can do with this, with DC sources, right? And including AC sources in this case. Let's see if anyone else joined us. It looks like we got somebody that has just joined us. Tell us if you can hear us okay. And I don't know who is the one person who is joined the live stream now. Could you give us your name on the chat? And we're discussing here a new tool that I've used that you guys can utilize for free. It's called Tinkercad. That's what my conversation has been all about, talking to myself. But hopefully this live stream will be recorded and I can replay it for you guys that didn't have a chance to join the conversation today. Thank you for your like. Where are you watching us from? I'm curious. And what, can you chat? Can you write in the chat? What courses have you taken with me? I appreciate that you're joining me tonight. There are thousands of students that I've helped in Udemy, and you come and represent them. So thank you so much for joining me on the conversation. Okay. And yeah, if you can chat and tell me where you are, your name, and what courses you've taken with me, I'd love to hear from you. Philip, yeah, thank you for joining us. Yeah, I can see your chat. I can see your chat. I don't know that you're able to send your video. I'm using a software here, but you can hear me okay, Philip? You hear me okay? I hope that you can hear me okay. Okay. Anyhow, thank you, Philip, for joining us in the conversation here. And I was chatting and talking about this new tool that I have found very useful and that is free to use. You're very welcome to, you can see on the chat, I have provided you a link. I have provided you a link to the course on Tinkercad that you can join me for free. And what I'm going to be doing there is putting out different kinds of ideas on engineering design, especially electronics. But I was talking to myself. Okay. Yeah. Thank you for taking that build a robot from scratch. Just a basic course. And as a matter of fact, you could review the concepts that you learned in that class using here this new tool that I'm talking about, Tinkercad. It's a very powerful tool. You can do all kinds of design ideas to be able to create systems and solutions. And so this is what we're talking about, right? This is our conversation today. And it looks like somebody else is joining us. Philip, did you have troubles finding the live stream at all? I had a little problem connecting my source here for some reason, but anyhow, I'm glad that you guys are chatting there and that you were able to join the conversation tonight. So let me continue the conversation. We got somebody else that joined us. on the live stream, and I'd love to hear from this other person. I don't know who you are. If you can just give me your name on the chat and tell me what course you did with me in Udemy, I would appreciate that. Well, we continue the conversation. I'm going to continue to monitor attendance here. So there's two of you. Thank you for joining me. And what I was explaining is that you guys can join me for a free course on Tinkercad. The link is on the chat. You can just join the class. And by doing so, you will benefit from a lot of different designs that I have there. Maybe you learn to use it as a wonderful design tool. So this was the last thing I was explaining on this screen. And what I was saying is that you have a lot of options and tools to be able to build circuits. Here we're looking at all the power supplies that you can possibly have, and with that, the possibilities to be able to do some work. Since we're all here, let me copy over this file, and I'm gonna create a new file here for us to be able to redo this. And so I'm gonna duplicate this file. And I'm gonna call this solar PV, right? Because there's a world of things that we could do with solar. I'm gonna get rid of these sources in here, and we're gonna build a little system here. So there is our solar panel. This is 5 volts, 100 milliamps. So that's quite a bit of current. And what we want to do is we want to be able to do some lighting. So I'm going to bring a couple of resistors in here. Okay, a couple of resistors. I'm also going to bring a couple of LEDs. And you can change the colors of these LEDs if you want different colors. And we're going to do a very basic design. First of all, let's see if the photovoltaic cell is delivering power. Okay, so I wonder who the other person is that is with us tonight, and I'd like to hear your name and any course that you've taken. Okay, so Philip, I'm going to resend the link back to you here. Here is the link for that particular class. Right there, Philip, that's the link for the class on Tinkercad. And you can just join for free there with your Gmail account or whatever. Okay. And while you do that, I'm going to continue to build this circuit. But one thing I want to do is verify if my thing is delivering voltage. So I'm going to read voltage from this photovoltaic source. Okay, I'm going to connect my meter. I'm going to change those colors to make it right. And if I run this, it's delivering 5 volts. That's so awesome. So we can trust that the thing is delivering exactly what's supposed to deliver. So with that, I am going to stop the simulation, and I am going to build a small circuit in here. Let's use some switches. For this purpose, and we can use any switch we want. There's push button, there's light switches, so we're going to use a couple of these push buttons. Okay. All right, so what I want to do is I want to bring power to this push button terminal 1A and connect this over, and I'm going to do the same for this other switch, but let's just try to build the first circuit and then we can add on, right? So that should be black. So let's run it. And if we press this on, we got a functional circuit. So we got a photovoltaic source that is allowing us to energize these LEDs. We can change these resistors, make them smaller, anywhere between 250 is probably all right. So I'm going to make them 250 ohms. Run it again, and that's a better light, right? That's a better light. So we have a functioning circuit. Now I'm going to bring power from this rail over to this rail. I'm going to change the color of that to red, and then I'm going to go over to the other circuit, and then of course I'm going to bring ground from this point to this point, and there we go. We got two circuits there that we can energize. I'm going to change the value of this resistor to make it 250 ohms, and now we have a functioning circuit that has two components involved, and that is being powered by a solar photovoltaic cell. So you could do a lot with these, and of course one way to power up circuits today is using solar photovoltaics. Okay, we can actually try to measure voltage across these resistors if we want to. Okay, so class code, Philip, that should be, let me see, let me see the class code here. You're already in, Phillips. Yeah, you were able to sign in, so I can see you right there. You're all set. So if you click on your class, what's going to happen is you're going to be able to see the circuits that I have. You already have access to the Tinkercad course, okay, Philip? You're great. You're good. All right, so we're almost at the top of the hour, but I want to finish up what I was saying for you, and that is this Tinkercad tool it's pretty good. So we can do a couple of things here. We could measure the voltage across these resistors. That's one thing we could do. So let's put a meter to measure that voltage. And of course, we can measure the current through the whole circuit. So I'm going to bring another meter, or I can just copy and paste this meter here. I'm going to copy and paste this and change it to make it an ammeter. And I'm going to break the circuit in here to be able to put in the meter to check out the total current that this photovoltaic cell is delivering. And so I'm going to change this to black. All right, and now we can verify both the functionality of the circuit, and it's delivering 11.7 milliamps, and 2 volts out of the 5 are going to the draining resistor, okay, and it's doing the same for the other branch. So there we go. Here we got a system that can be used for one or the other. And so we could even tweak this circuit to use it with one single switch. That's another thing that we could do. Or we can use them in sequence. Yeah, there's a lot of circuit design that you could do, Philip, with this tool. So I'm glad that you got in, and what you're gonna see in that class is that I will publish different kinds of things. If you go to the activities, you're gonna have access to a folder called Basic DC Circuits, and there's a bunch of circuits in there, Philip, that I've created for you guys, whoever joins this class, to use. And maybe in the future we'll do more sessions to demonstrate the power of this tool. All right, but that's all I think I wanted to do today. This live stream is being recorded, and it's going to be available for review. But I wanted to give you some time, Philip. If you have any questions for me, I'll be glad to answer any questions you might have. Well, thank you, Philip. That's so awesome that you say that. And I hope the best for you. I hope that that you're picking up your skills, and that hopefully at some point you can use these skills for the improvement of your own life. No, I have not played with BIM robotics. There are so many brands out there, as you may know, Phillips. There are so many brands, especially today. So I grew up, playing with Lego, Mindstorms, and that kind of technology. And of course, that's very popular in academic circles. Then I've done first robotics, and then I played with a few other bots, but not this particular brand of BIM robotics that you mentioned. I bet it's fun, isn't it? Have you done some work in that area with this particular brand? So you're probably learning about this BIM robotics. I will do a little search on that particular brand. Are these mobile robots? Are these stationary robots? Are these industrial robots? Okay. Yeah, okay, yeah. This smart Titan person is very famous. So he's built his own robots. And there's a few others that have come out with that. I just haven't had the time to, put it into building a single robot myself with my teaching responsibilities, having to prepare too many labs. It's hard for me to just focus on that. Maybe in the future, but I'm glad that you're connecting with somebody who's building those robots. I have one that I actually bought a kit that I have been putting together, and I'll bring that up at some point when we meet again to show it to you. It's a multi-axis mini industrial robot. I forgot what the brand is. I bought the kit when I was curious about their parts and so on and so forth. Anyhow, Philip, thanks for stopping by. We're gonna leave it there for tonight. I appreciate your visit tonight, and thank you for continuing to be in communication over Udemy and other connections that we might have. Appreciate your time tonight, and good luck to you with learning new robotics technology. Sounds like you're excited about that, and that's very promising. Anyone with robotic skills today will have good opportunities. I'll say develop, and go into a brand that you can benefit from as you look to using your skills and talents in the future. But thank you so much for coming. We're gonna leave it there for tonight. Have a good evening.